Scientists have just announced a terrifying structure of advanced alien species lurking in the vastness of space. The bizarre signals coming from this alien megastructure have confused astronomers, and you won't believe what they discovered in its vicinity. The weirdest star in the cosmos just got a lot weirder, and yes, it might be aliens. Tabby star, also known as KIC 8462852, has been puzzling scientists for years since its brightness has been fluctuating in mysterious ways. Explanations ranged from a cloud of comets to extraterrestrial megastructures around the planet. Now, an analysis of past observations shows that the star has been slowly getting dimmer for more than 100 years, leaving everyone wondering what it has been hiding. Mystery blips. It all started in 2011 when citizen scientists working on the Planet Hunters project began analyzing data from NASA's Kepler spacecraft, which, during its 4 years of primary observations, detected the telltale signs of over 2,300 planets. Planetary transits cause brief, predictable dips in star brightness as the planets pass in front of or behind their host stars. Kepler observed dips in Tabby star, but they didn't line up with anything that looked like a planet's shadowy fingerprint. They seemed more intense and seemingly at random. Astronomers were able to explain the strange behavior of the star, formerly known as KIC 8462852, after they were first made aware of it. Strange dimming events were only a small piece of an otherwise unusual behavior pattern for this star. Speculations included our own solar system's material, stellar fluctuations in Tabby star, dusty debris disks surrounding black holes, and last but not least, alien megastructures. Strange in many ways. Since such a multi-decadal dimming seems impossible, the claim sparked debate. Stars maintain a nearly constant luminosity for billions of years after birth, only undergoing rapid changes shortly before they die. In contrast to Boyajian star, these rapid changes occur on a timescale of millions rather than billions of years and are accompanied by obvious markers. From the looks of things, it's just another middle-aged star. It's not a variable star, and there's no sign of it pulsing with a regular beat. In addition, there's no evidence that it is accreting material from a companion star, that it is undergoing anomalous magnetic activity, or that it is young and still forming, all of which would cause a sudden change in its luminosity. Apart from the peculiar dimming, this star appears to be completely normal in every other way. Even when astronomers Benjamin T. Monte and Joshua D. Simone double-checked Schaefer's claim using the original, less well-known Kepler calibration data, it still held up. Over the course of the 4-year Kepler mission, they discovered that Boyajian star faded by 3%, an effect as remarkable as the shorter-term dips. Boyajian star has displayed two puzzling phenomena: a gradual dimming over the past 4 years, and possibly the past century, and deep, irregular dips lasting days or weeks. Astronomers would love to have a simple explanation for both phenomena, but it's already challenging to explain either one on its own. Many answers, none persuasive. Here we consider some of the most oft-proposed scenarios to explain the bizarre observations of Boyajian star, a disk of dust and gas. Tabby star isn't the only one to experience periodic dips and long-term dimming. It is common around young stars with planets still in the process of forming. Planets form in the clumps, rings, and warps that form in the disk of gas and dust that circle these stars, which is heated by the star's light. These features can momentarily obscure a star's brightness in edge-on disks, and over decades or centuries, a writhing circumstellar disk can block an increasing fraction of the star's light. There does not appear to be a disk around this star, and it is not a young star. Boyajian star doesn't show any excess infrared radiation, which would make sense if the disk were warm. It's possible that the dust and gas form a thin ring that sprawls widely around the star, blocking the star's light along our line of sight without generating much infrared excess. Around a middle-aged star like Boyajian's, such rings have never been seen. We find this scenario highly unlikely because it requires the introduction of a phenomenon never before observed to account for Boyajian star: a swarm of comets. At first, Boyajian thought that giant comet swarms passing in front of the star were to blame for its dimming. After all, comets spend most of their time in interstellar space and have extremely erratic orbits, both of which may contribute to their sporadic fading. Whereas, what about the cold weather? The comets would get hotter as they got closer to Boyajian star and cool down rapidly as they moved away. As a result, any infrared surplus would be discernible only during a fall, No infrared excess is currently being picked up, which could be explained by the fact that the comets responsible for the dips a few years ago are now extremely distant from the star, making them extremely cold and emitting no detectable heat. However, any cometary swarm large enough to cause the mysterious long-term dimming would inevitably produce an infrared excess, which is lacking. Therefore, we conclude that a cometary explanation is likely for the brief brightenings, but highly improbable for the more permanent dimming. However, if comets are not responsible for the long-term dimming, then it follows that they are also not responsible for the dips. A cloud in the interstellar medium or solar system. Gas and dust floating around in space dim the glow of stars. Perhaps, as Kepler's line of sight passes through different parts of this material as it orbits the Sun, a cloud or dense sheet of it blocks a varying fraction of the light. It's possible that the long-term dimming of Boyajian star is caused by a density gradient in such a cloud, and that the extreme short-term dips are caused by small knots of material. The research conducted by U.S. Naval Observatory's Valery Makarov and his associate Alexei Golden lends credence to this theory. They claim that the faint dips in brightness attributed to Boyajian star are actually deep dips in brightness from fainter adjacent stars in Kepler's field of view, and that these dips are likely caused by swarms of tiny, dense clouds or comets in interstellar space. We rate the plausibility of this theory as high. One related theory proposes that the obscuring cloud might be located on the outskirts of our solar system. If that were the case, then every year during Kepler's orbit around the Sun, the spacecraft's line of sight would pass through such a cloud. However, we don't observe any yearly repetition to the dips of Boyajian star. In addition, there is presently no evidence to suggest the existence of such a cloud. A cloud of ice and vapor rising from geysers on a Pluto-like body much further from our Sun is conceivable but unlikely in our opinion until planetary scientists weigh in. Alien megastructures. After ruling out a wide variety of natural causes for Boyajian star's peculiar behavior, we can turn our attention to the most sensational possibility: an alien megastructure, like the one described by Dyson more than half a century ago. Let's pretend an alien civilization constructed a vast array of energy collection panels, each of which orbited a different-sized star. The swarm of smaller panels would act like a translucent screen, blocking out some of the star's light, but letting through the rest. Variations in brightness on timescales ranging from the hours to the centuries may be seen as denser parts of the swarm cross our field of view. Astronomer Luke F. A. Arnold first noticed this phenomenon over a decade ago, and it was due to large panels or groups of panels flying in formation, causing huge, discrete dips related to their geometric shape as they transited. Similar issues with insufficient infrared emission exist for the circumstellar disk hypothesis. Aliens' massive structures are still bound by the laws of physics, so any starlight they absorb must be converted to heat and radiated away. This stipulation remains true regardless of how advanced their technology becomes. Since energy can neither be created nor destroyed, if they're collecting a lot, they must eventually release a lot. There are still ways to make the hypothesis work, such as if a swarm of megastructures, instead of emitting heat, radiated radio or laser signals. If the swarm did not form a sphere, but rather a ring precisely aligned with our line of sight, or if the swarm used some form of technology that was beyond our understanding of physics. This hypothesis is challenging to test due to the large number of variables. If all natural explanations are eliminated, then the alien megastructure hypothesis becomes a viable alternative. On the other hand, if we were to detect obviously artificial radio signals being transmitted from the vicinity of Boyajian star, a search we have already begun with Boyajian using the Green Bank telescope in West Virginia, it would lend credence to the theory. We do not yet know enough to even qualitatively assign a probability to the actions of hypothetical alien life, so our verdict on the most sensational hypothesis to explain Boyajian star is that its plausibility is unclear. An unknown but bright future. So, where do we stand now in our quest to decipher Boyajian star? Since no excess of infrared energy has been detected, we can discount any explanation that depends on its presence. Until all other possibilities are exhausted, we can also rule out scenarios that involve a large number of improbable occurrences or the use of previously unknown physical principles or objects. More research is needed to determine the best way forward. In order to gain access to the Las Cumbres Observatory Global Telescope Network, Boyajian, now an assistant professor at Louisiana State University, successfully crowdfunded to buy time on the telescope. The extra vigilance paid off on May 20th, 2017, when the star's brightness began to dip again, this time by nearly 3%. During the dips observed by the Kepler mission, we lacked access to spectral information, but thanks to the efforts of amateur astronomers around the world, we now have it. Our goal is to use this information to disprove alternative explanations and propose new ones. To better understand the star's gradual dimming, other astronomers are looking for additional historical measurements of its brightness. To better constrain theories about the strange light curve of the star, knowing the time scale of the dimming would be helpful. We also await a more precise distance measurement to Boyajian star, which is expected from the Gaia mission of the European Space Agency and should help rule out some possibilities. Extinction due to gas and dust in the interstellar medium cannot account for the current level of dimming if the star is closer than 1,300 light-years. Long-term dimming may be due to random patterns of intervening dust along the line of sight if the distance is instead around 1,500 light-years, the current best estimate. However, Metzger's team suggests that the dimming could be the result of a return to normalcy following a merger if the star is much farther away than that. Until more data becomes available, all we have to go on when trying to guess what Boyajian star is like is our imagination and a healthy dose of physics. The search for the meaning of this mysterious star is ongoing, much like the solution to the best natural mysteries. That pretty much wraps this video up, guys. Thanks for watching. So, what are your thoughts about the alien mystery surrounding the Tabby star? Share with us in the comments below. Make sure you subscribe to this channel with a bell notification if you enjoy watching our content. We upload some awesome stuff here which you will most certainly enjoy. Hit a like on this video and leave a comment below. See you guys in the next one.